All right, we are live in our TExES study and test prep group on Facebook. I show it's just about 3 o'clock, so we're going to go ahead and get started. If you don't know who I'm Dr. Christy Mulkey, and I'm the workshop coordinator for 240 Tutoring. And I am live every Tuesday at 3 o'clock right here in our Facebook group to do some videos to help you prepare for your exam. Now, the past couple of weeks, we've been looking at EC-6 math, and we're going to be finishing that up this week and next, and then we'll be moving on to another subject. So if you're with us and you have a question at any point along the way, just drop it in the comments. Even if you're watching this later and the live has ended, go ahead and drop that comment in there, and I'll tell you at the end of this video how we address those and some other supports we have in place for you. So we're gonna get started today looking at EC-6 math, competencies 4 and 5. If at any point you have a question, drop it in the comments. I've got another device sitting right here where I can see those comments coming up. So I'm gonna share my screen with you. So give me just a second to do that. You should be seeing my PowerPoint. And make sure that's working. Yes. I've been having internet difficulties at my house today, so I apologize if there is a little bit of a lag between my mouth moving and the words you're hearing. So we're going to go ahead and get started. And again, we're looking at competencies 4 and 5 of the math portion of the EC-6. So this is specific to TExES and specific to the EC-6 exam. I'm going to walk you through those competencies, and we're going to look at some practice questions together, and I'm going to try to teach you some strategy and some skills, some content, and give you some explanation about why the answers are right and why the wrong answers are wrong. So let's jump right in. We're looking at competency 4 today, which is geometry and measurement. And that is right here. It says the teacher understands principal concepts of geometry and measurement, and a lot go into this. You can see all these descriptive statements that are listed here, and there are a lot of them. It's looking at figures, angles, 3D figures, 2D figures, looking at money, mass, time, conversions in measurement, and so on. And so there's a whole lot that you need to read and be familiar with here. If we look at competency 5, we're looking at probability and statistics. My pen has been all crazy today, so we're going to try to get it to cooperate. But not only knowing the TEKs that go with that, but understanding basic statistical things like mean and median, mode, range, knowing how probability is described in terms of outcomes, and then looking at how do we represent that in graphs and charts and interpret that. So we're going to do some practice questions today to try to help you with this. I'm going to check on the comments really quickly. All right, just making sure that no one has a question yet, so that's awesome. All right, let's jump into these practice questions. Now, these come from the ETS website. These are the free and public questions that are in the preparation manual or right there on the ETS website, but I'm going to walk you through those so that you understand the math behind them. So we're going to look at question 40, which addresses competency 4, looking at 3D figures. And it's really short. It says, which of the following geometric solids has 5 faces, 5 edges, and 5 vertices? Now, to answer this question, you actually don't have to do any math. You just need to know some vocabulary. First of all, you need to know what a face, what an edge, and what a vertice is, or are, what vertices are. So if we're looking at a 3-dimensional figure, so I'm just going to draw a basic rectangular prism. Okay, and we want to look at what are the faces and edges and vertices. The vertices are very easy. They're the corners, guys. It's where the edges meet. So these are all the vertices on this prism. The edges are the line segments. So the line segments, where the line segments meet, form the vertices. So the edges are the lines, the vertices are the corners. Now, mathematically speaking, we can get much more technical than that, but for the sake of this test, if you can remember that. The faces are the shapes that are made within those flat surfaces, within those edges and vertices. So the bottom of this rectangular prism is a face, the top is a face, and then you've got all the ones in the body, okay? So I'm gonna erase that just so we can easily see what's going on. I'm gonna need all the white space I've got here, all right? Now it's asking us which has 5 faces, 8 edges, and 5 vertices. And you've got a pentagonal pyramid, a rectangular pyramid, an octagonal prism, and a triangular prism. So here are 2 other terms you need to know. This is all about your geometric vocabulary. What do you know? If it is a pyramid, guys, has a flat base that comes to one vertex. So that base can be in any shape. I can take a square or rectangle and I can make that into a pyramid. I can take a triangle and make that into a pyramid. But notice it's got one flat base and all the edges leaving the vertices of that base come to one vertex. Sometimes you'll see it called an apex at the top. That's what makes a pyramid. Now, a prism, on the other hand, will have 2 bases of the same shape that are joined, okay, by edges in the body. So you can take any 2 shapes. So I'm going to draw that rectangular prism you saw me draw just a minute ago. All right, so there's my 2 bases, and I join all the vertices up, and that becomes the body. I can do this with any shape as long as the shape on the top and the bottom are the same. And then we join up those vertices. That's what makes a prism. So a prism is going to have the same 2 bases. So either way you flip it, it's going to be the same shape. And then the corners are going to join with those edges in the body. Okay, so a pyramid comes to one vertice at the top. Prism has 2 flat shapes. Okay, you can set it either way, so that either way becomes the base. So now we know what a pyramid and prism are. A pentagonal pyramid is basically going to be, you name the pyramid by the shape that's at the bottom, all right, the base. So this was a triangular pyramid, this was a square pyramid. A pentagonal pyramid is going to have a pentagon at the top, or a 5-sided figure. So then we can take a vertice or one vertex at the top. Oh, that's a terrible line. Stick with me. And we make it into a pyramid. A rectangular pyramid is going to have a rectangle at the bottom, okay? An octagonal prism, just like a pyramid is named by its base, prisms are named by their bases, except now instead of 1, you're going to have 2. So an octagonal prism is basically going to be the same thing, but at each end you're going to see an octagon. A triangular prism is what I've drawn here. Now, whenever I see a question like this, I always start with vertices, and let me tell you why. Vertices are the easiest to count. When you start trying to count faces on a drawn 3-dimensional figure, it can get real easy to miss one. Same thing with edges. I like to use a highlighter, draw it, and then use a highlighter over it to highlight the edges, but that can be difficult too. So I'm going to start with vertices, and I'm going to see which one would have 5 vertices and then work from there. So if I'm looking at a pentagonal pyramid, so a pentagon will have 5 sides. For every side, you're going to have a corner. So we know just on the base, we're going to have 5 corners. And then, of course, you have the one at the top. So that one has 6 vertices. So A, we can rule out. You see my strategy here? The easiest one to count. A rectangular pyramid, so I'm going to draw a more clear rectangle and make it a pyramid. And I'm going to count those vertices. Easy to count the corners. 1, 2, 3, 4, 5. Okay, so that one checks out. It has 5 vertices, so I'm going to leave it alone. Octagonal prism. Well, we know if octagon has how many sides? 8, like octopus, okay? So if I draw an octagon, which is real fun here on this screen, and it's going to be all wonky, but just bear with me. For every side, there's a corner. So if an octagon has 8 sides, it's going to have 8 corners or 8 vertices. That's just on one. I haven't even drawn the other ends yet. So we can rule out octagonal prism. It's going to have way more than 5 vertices, way more. And then I'm going to go to triangular prism. I've already drawn one of those. I'm going to count the vertices. 1, 2, 3, 4, 5, 6. 6 vertices. So I can rule out this one. So just based on the number of vertices, I can answer this question. The answer is B. The answer is B. If I want to check myself, I can go back and count the edges and the faces to be sure. Now, I'm going to do some erasing real quick because I want to show you some tricks. That one was pretty easy because we were able to count the vertices and only one had 5 vertices. But what if it only asked you about faces and edges and you're like, how do I count those? That's so confusing. I want to show you a couple of tricks. So if you run across a question like that, you can answer it. So I'm going to give you a trick for counting edges, all right? In a prism, however many edges you have on one base, so the number of edges on one base, you're going to have it on both bases. So you're going to have that times 2. All right? Everybody with me? And then you're going to have the same number of edges in the body. The same number of edges in the body. So you could really do this times 3. Now this is for a prism. Okay? So that's how you can count edges. If you can just count the bottom, all right, you will have the same number of edges on the top and the same number of edges in the body, okay? So everybody with me so far? That's how you can count edges quickly. Faces, everybody with me? So if I have a rectangular prism, drawing it to look a little bit differently this time. Okay, I know for every edge on the bottom, there's a face in the body. So here's how you count faces on a prism. All right, you're going to have both bases. So you're going to have the top, the bottom, and then you're going to count the edges on the bottom, whichever base you want to count. 1, 2, 3, 4. So I know I'm going to have 1 on the top, 1 on the bottom, and since I have 4 edges on the bottom, that's going to equal 4 faces in the body. So a triangular prism has 6 faces. That's easier than sitting there going 1, 2, 3, 4, 5, and trying to remember which ones you counted. It's very difficult to count with just a drawn figure. So that is a great way to remember how to count faces. In a pyramid, I'm going to erase again. So I know y'all are like, she's taking a long time on this question because it might not look just like this one. And you're going to need to know how to count those faces, edges, and vertices. Okay, so if we're looking at a pyramid's a little bit different. When we want to count faces, so let's look at that square pyramid. When we want to count faces, you know you have the base at the bottom, so you have that base. The same rule applies that did to prisms, except there's no top. So for every edge on the base, 1, 2, 3, 4, real easy to count, there is the same number of faces in the body. So the number of edges on the base is going to equal the number of faces in the body, just like the prism. But now you only have one base to count. So I have the base gives me 1, and in this instance, there's 4 edges on the bottom, so there's going to be 4 faces in the body. I have 4 faces here. So that makes it much easier to count. When we want to count the edges in a pyramid, for every corner, you're going to have an edge going up to the top vertex. So if you have 4 corners, you're going to have 4 edges in the body. So you count the edges on the base, all right? And then the edges in the body, all right? So if you have 4 edges down here, which is going to give you 4 corners, you're going to have 4 edges in the body. So I hope that helps you a little bit. I would not try just trying to visualize this and count it. Learn this strategy. Now, it's funny, when I was prepping this video last night, my daughter happened to be sitting in the room with me, and she goes, Mom, one of my old math teachers just told me, memorize the basics. So she made a flashcard with the faces, edges, and vertices for the most basic prisms. She did rectangular prism, triangular prism, and by the way, square and rectangular would be the same. And then she did pyramid, square, rectangular, and triangular. She said, now, doesn't help you with the other ones, but those basic ones you can just memorize. So if that works for you, by all means, take that memorizing strategy and go with it, okay? So hopefully this helped you a little bit. We're going to move on to that next question. So this one was all about terminology, all about terminology. Now, competency 4, again, still looking at measurement, but this one's a lot more wordy. So let's talk through it. It says, which of the following statements best explains why the algebraic formula for the area of a triangle is 1/2 base times the height? Now, I'm not even going to look at these answer choices yet. I want to talk you through this one. Most people can remember that the area formula for a rectangle or square is length times width, or we can rephrase this as base times height. And you might be thinking, why can we do that? Well, if I draw a rectangle and we picture it laying down, and this is 4 and this is 6, you're thinking, well, the length is 6, the width is 4, or vice versa. Just now picture the rectangle standing up. Just picture it standing up. Instead of picturing it laying flat, just picture it standing up. So length times width becomes base times height, or you'll see it written when we have 2 letters next to each other, it implies multiplication in the middle, base times height, okay? So everybody knows that one for a rectangle or square. Easy enough, okay? Now, I want to show you something about a triangle, why this formula works. I'm going to draw a rectangle right here for you. Now, I'm just going to split this in half diagonally. Everybody with me? So I'm going to take any of the corners or the opposite corners and join them with a diagonal line. What do you notice has formed? What do you notice has formed? I have a triangle right here, and I have another triangle right here. Okay? So really, to get the area of any triangle, I just turn it into a rectangle. So if I gave you this triangle, just turn it into a rectangle or square. And the base of that triangle could have been, 5, and the height of that triangle could have been 6. We can multiply those together to get the whole square, or rectangle in this sense, barely a rectangle, divide it in half, and now we just have the area of the triangle. How many of you were ever told we need a square piece of paper, and you did the old trick from elementary school? Here, I'm going to hold up a piece of scratch paper if you can see me in this tiny little window up here. And you're like, take this construction paper and make a square out of it. You did this thing. I can't fold it and hold it up in the air. You did this trick. All right, and then you cut off the bottom to make it a square. Basically, you made a little triangle to make that little square there. It's kind of the same idea. I can take any rectangle and I can divide it diagonally into triangles. If I know the area of the rectangle, I can now split it in half, and I know the area of the triangle. If I start with the triangle, I can make it a rectangle or a parallelogram. I can even take like this obtuse triangle. All right. And it gets a little tricky because it actually becomes a parallelogram, and it's the same basic principle. I can find the area of the whole thing. That triangle now becomes half. So really, we're looking at 1/2 base times height. So sometimes you'll see that area for a triangle written 1/2 BH, or sometimes you'll see it written BH divided by 2. Same thing. So now let's read through these answer choices and figure out which one is correct. A parallelogram can be transformed into a rectangle if a triangular piece is moved from one side to the other. That's even hard to picture. I've got to move a triangular piece over here to make that a rectangle. That really doesn't help me with this formula. All right. The height of a triangle is not equal to the length of one of its sides, and the length must be divided by 2 to be used to find the area of the triangle. That doesn't describe what we just talked about. A parallelogram is composed of 2 congruent triangles. So the area of a parallelogram with the same base and height as the triangle can be divided by 2 to find the area of the triangle. Guys, that's what we just talked about. The formula is only true for scalene triangles because all of their sides are different. That's not true. Because if you look at any math formula chart, and if you've grown up in Texas, you've looked at a lot of them, then you know that formula doesn't say for scalene triangles only. So D is not correct. C is the correct option here. So hopefully that helped you understand. If you can't remember how to find the area of a triangle, just remember 2 triangles, 2 congruent. You can place them on top of each other, make a rectangle, and then you can see, well, area of the rectangle, base times height, split it in half. Okay? So let's move on to our next question. Question number 44 is again talking about measurement. Now, I'm gonna have to look over here at my big screen, so if you see me looking sideways, it's just because these glasses aren't strong enough to see this itty bitty font, so hopefully you can see it well. It says, Archimedes' summation puzzle from about 200 BC, in which a 12 by 12 grid is divided into 12 different polygons is shown above. A 3rd grade teacher is using the puzzle to determine whether or not students are able to partition or decompose non-standard polygons to find their areas. Which of the following polygons should the students be asked to find the area in order to demonstrate this skill? Wow, really wordy. Now I'm going to help you out here. You don't need this whole first sentence. So if this sentence is hanging you up, you don't need it. Oh, well, there goes my pen. Okay, so let me erase that. Just know you don't need the first sentence. You don't need it. It's irrelevant. I'm going to try that again, see if I can't actually cross out that first sentence. There we go. All of this is pretty irrelevant. All right. What we need to know is this teacher's trying to teach her students. Don't you love how they throw some pedagogy in with some math just to throw you off? Is trying to teach her students how to partition or decompose, so break it apart, deconstruct it, non-standard polygons to find the area, okay? So, for instance, what they mean by non-standard polygons. If I gave you this shape right here and asked you to find the area, well, there's no formula for finding the area of this non-standard polygon. It is polygon, it's 2-dimensional, 3 or more straight sides, closed figure. We would actually have to decompose it, break it into 2 separate polygons where we know we have formulas. I can find the area of this rectangle, and then I can find the area of this triangle and put them together to know the area of the whole shape. So basically, what this is looking at is which of these figures below show us non-standard polygons, because that's what she's wanting them to do, non-standard polygons. So we're looking for things that are not rectangles, squares, triangles. We're looking for things that are not those things. So let's look at each of these figures. Now, notice this one. These are the trickiest questions you're going to find on the test. Select all that apply. So you're going to have more than one correct answer, most likely. Most likely. They don't usually give you one of these and there's only one that's correct. Okay? So classic mistake number one is only choosing one and moving on. It says select all that apply. So I'm going to look at each of these figures and I'm looking for the ones that are non-standard. So figure one, I'm going to have to look at my bigger screen, is over here. So we're looking at, I can't draw it looking at that big screen. This figure right here. That is definitely a non-standard polygon. So A would apply. All right. Now I'm going to look at figure 3. Figure 3 is right here. What shape do you see? Triangle. I don't need to decompose that or partition it, or what was the words they use? Partition or decompose. I can find the area of that triangle. I have a formula for it. It's very easy. And so 3 is not a non-standard polygon. It is standard. I have a formula for it. So it would not apply. I'm going to look at figure number 5. Right here. Does that look like a square, rectangle, or triangle? No, it's a non-standard polygon. So figure 5 would work. Let's find figure 8. Right there. It's similar to that one I just drew for you, actually. Figure 8 is a non-standard polygon. I would have to break that apart. So that one applies. And then figure 12, way up here, we've got a triangle. So that is standard. It would not apply. So in order to get this question correct, you would have to choose A, C, and D. You're looking for all the ones that are non-standard polygons. How would I take these apart in order to find the area? So if I were looking at like figure number 1, I would probably split this into some rectangles and triangles to make this work. Okay? So that one, again, knowing your vocabulary. Knowing your vocabulary. Now let's look at this one, probability. This is competency 5, probability. After learning the theoretical probability of a two-sided coin landing on any one side, students work in groups to flip the coin several times and get the following results: 9 heads and 6 tails. Okay? Based on the scenario, which of the following observations made by the students about probability is accurate? Now, the first thing I'm going to do is write these out as fractions. When we write probability, we write it as a fraction with the numerator being the outcome we're trying to measure and then the total possible outcomes, okay? So I'm going to write the theoretical. They know that the probability of a two-sided coin landing on any one side, heads or tails, is going to be 1 out of 2. So that's our theoretical probability. Now, experimental means we actually test it out. They flipped that coin a total of how many times? 9 plus 6 would be 15. So for heads, it had a 9 out of 15 experimental probability. And for tails, it had a 6 out of 15 experimental probability. Okay? So let's work through these answer choices. It says A, the theoretical probability of a coin landing on heads, 0.5, is equal to the experimental probability obtained. So we know we can write 1/2 as 0.5, so that part's correct, but it's equal to the experimental probability. Did either of these equal half? 9 isn't half of 15, 6 isn't half of 15, so A is not correct. B, the theoretical probability of a coin's landing on heads is less than the experimental probability obtained. So is this less than our experimental probability? All right, half, 9/15 is more than half. 6/15 is a little bit less, but not much. And if we combined these, it'd be definitely more than half. So B could be the answer, because that half is less than our experimental probability. C, the experimental probability of a coin landing on heads, 0.6, is lower than expected. Well, this actually doesn't translate into 6/10. So that in no way is accurate. And D, the experimental probability would have been more accurate if the students had decreased the number of trials. Now, this one's tempting to choose if you don't know some basic statistics. Let me give you an example that I used to use with students all the time. If I was going to give a survey and I wanted that survey result to represent what the whole group wanted, I would want to give that survey to as many people in the group as possible. Because the more surveys I get back, the more accurate that data is. So we need that experimental number to be as large as possible. So statistics tells us that the larger the sample size, the more close we get to the theoretical probability. So the more times I flip that coin, more and more and more, I'm going to get closer to this theoretical probability, not decreasing the number of trials. I would need to increase the number of trials to get close to that theoretical probability. D is not correct. It is B. So this one just requires some thinking. All right, we're going to move on. Now, in the preparation manual, there were only 4 questions for this competency. There were 3 for competency 4 and only 1 for competency 5. So I wanted to give you at least one more practice question for competency 5. We're running out of time, so I'm going to move through this really quickly, okay? So here's one about mean, median, mode, and range. So that statistical verbiage you need to know. It says, what is the median and range of the data set below? So you need to know those things. Mean is average, where you get the sum of all the numbers and divide by that number of add-ins. The mode is the number that occurs most frequently. So if we were looking at the mode for this, I see 26 in here twice and none of the other numbers repeat. So 26 would be the mode. The median is the middle number when put in order from least to greatest or greatest to least. And if you have 2 numbers in the middle, you average those 2 numbers together. And the range is the difference between the highest and the lowest. If you don't know those terms, you need to learn those. You need to learn those. So if I want to find the median and the range, the first thing I'm going to do is put these numbers in order from least to greatest. That's how I like to operate. Now, a little strategy I used to use, I would see students so many times, they'd go to put them in order and they leave a number out because they get in a hurry. So as I list the number, I'm just going to cross it out. 18, next smallest I see is 24. Next smallest I see is 26. And I have 2 of those. And students would ask me, can I just write it once? No, 26 occurred twice. So we write it twice. It's like if you made a 26 on 2 different assignments in the grade book, it counts twice. All right. And then we have 27. And then we have 33. And the last one, 35. This ensures I get all the numbers in my list. I know it takes a second, but it's worth it so you don't miss the question. Now, if I want to find the median, I've got to find the number in the middle. So I'm just going to start crossing them off on each end. Take 1 off each end till I get to the middle. And I have 1 clear number in the middle, so my median is 26. If I had had 2 numbers, if 26 and 27 had been in the middle, there'd been 2 middle numbers, then I would have just found the average of those 2 to get the median. So now that I know that my median is 26, I can rule out answer choice A and B. Now I've just got to find the range. And guys, you just need to know the range is the difference between the largest and the smallest. So putting them in order again helps, real easy to see. 18 and 35. Find the difference, 35 minus 18. Going to do a little regrouping here. I'm showing you my math just so you can follow along. And the range is 17. So the correct answer here is C. So hopefully you found that helpful. Remember, I've said it every week, you need to know the test format. You need to know the test format. Know how many questions you need to get right and work that process as you practice. Remember, there's no calculator. So it really helps if you know your basic facts. Really, really helps speed up the process. The most common thing I saw with candidates taking this test on the math section, they ran out of time. So if you know those basic facts, that's going to help you. I said it last week. I'm going to say it again this week. Also, there is no formula chart. No formula chart. So you need to know some basic formulas, or at least understand how they work. Know some real basic ones so that you can build off of it. If you don't know those formulas, go grab you an 8th grade math star mathematics chart and just study that till it gets familiar and you at least have some idea what those formulas are. Familiarize yourself with what the system looks like, so when you take that test, you know what the screen's going to look like. Practice your pacing. It doesn't help to just do the math. You've got to learn to do the math quickly. And you have to learn what takes you a long time. Skip things that take you a long time. Flag it and come back to it. Know that if you have complicated problems with volume and surface area that are multiple steps and require conversions of units and all that, you're looking at 5 minutes on a problem. Skip that one, come back to it, because I'd rather you do 3 in that 5 minutes that you know you're going to get right and miss that one. Okay? But if you take too long on one problem, you may end up with a whole bunch at the end that you miss. So practice the pacing. All right, guys, if you need more information, you need more help, you need study materials, I highly recommend you check out our study guides. We do have some free resources that can help you. All of these videos I'm doing stay in our Facebook feed here. So you can either scroll through the group feed or you can find them in the videos tab over on the side. You can go back and watch the last 2 weeks where we talked about competencies 1 through 3. Next week, we're going to talk about competency 6. If you want to go find them on YouTube, we upload all these videos to YouTube so you can go check them out there. If you're watching this later and it's not live, drop a comment. I will come back on Wednesdays. I do office hours right here in this group where I go in and try to answer as many posts and comments as I can during that time. So if you have a question, even if you're watching this later, put it in the comments. I will see it and I will try my best to help you. You can post anything in this group and I will try to come back during those office hours and help you. If you're watching on YouTube, if you're watching this video on YouTube, go join our Facebook group if you want me to see those comments and get a faster reply to your question. I'm going to take a look at our comments and make sure there's nothing I need to answer before I head out, and I don't see anything. So I hope this video was helpful for you and that you will join me next week at 3 o'clock Central Standard Time right here for the last competency of the EC-6 math exam. So I will see you then, and I wish you the best of luck. Again, I'm Dr. Mulkey with 240 Tutoring. Thank you so much.